Let's look at two more examples of using the square root method. Now, you'll notice this first example, x squared is equal to -18. The x squared is already isolated, so we don't need to use the isolation principle. So all we're going to do is take the square root of both sides, because a square root undoes a squared, and we'll be left with x is equal to the square root of -18. Okay, but let's be a little careful with this. 18 is 9 times 2. So this will simplify to 3 square root of 2. And what does that negative do? Remember, we're no longer going to say no solution. We're going to say that is an I. So x is equal to 3 square root of 2 I. What have I forgotten? That's right. If you have something squared, there should be two answers. So when you take the square root of both sides, you've got to remember to add plus or minus. So the square root method can also result in imaginary answers. We need to keep that in mind. Now, probably the hardest problem that you're going to see is this next one. Something like 2x plus 1 squared equals 36. Now, it's already isolated. So all we need to do is take the square root of both sides here. So we get on the left, the squared and the square root cancel. So we're left with the inside 2x plus 1. And we're going to remember to add our plus or minus, and the square root of 36 is 6. Now this is different than a previous problem that we did where there was an answer here that has a square root in it. And you would be tempted at this point now to say, keep going on this problem and go, okay, well, we'll subtract 1 from both sides, and that'll give me 2x is equal to plus or minus 5. So x is going to be plus or minus 5 halves. A lot of students do that, and that is actually very wrong. So what we just did here is incorrect, because let's look at what actually is happening here. When we say 2x plus 1 is equal to plus or minus 6, that's actually two separate equations. So we have 2x plus 1 is equal to positive 6, and 2x plus 1 is equal to negative 6. And I'm going to write those down separately because 6 is not a square root like square root of 4, or sorry, like square root of 3 or square root of 12. It's an integer number. We're going to have to write this as two different equations. And let's see why. When we solve the first one of these equations, we get 2x is equal to 5. So x is equal to 5 halves. And remember, when we did it wrong, we got an answer of positive and negative 5 halves. So positive 5 halves is a correct answer. And you may be thinking, Mrs. Hoffman, um, you're doing it wrong. We could have just done it the other way. But let's see what happens with this second one. When we subtract 1 from both sides here, what do we get? We get -7. So x is going to be -7 halves. So when you are using the square root method and you end up square rooting both sides, and the other side is an integer, 6, 5, 12, 22, whatever it is, if it's an integer, you have to write it as two separate equations and solve each one individually, because doing it with a plus or minus isn't going to work.